Alright, and welcome to Algebraic Transformations, Level 3. Now, in number 1, it says the function f of x equals 4 parentheses x plus 6 squared minus 3 is changed to g of x equals 3 f of x minus 2. Okay, describe the transformation. The first thing we see here is that our a value is equal to 3. And so we know that when our a value is greater than 1, which we would agree that 3 is greater than 1, we know that we have a vertical stretch, comma. The next thing I say is, well, anytime I have any sort of expression inside the function, so in this case, x minus 2, we always set that equal to 0. In order to solve for x, the opposite of minus 2 is plus 2. I add 2 to both sides, and x is equal to positive 2, telling us that it is going to translate to the right 2. So I see I have a vertical stretch, and I'll be shifting or translating to the right 2. Okay, for part B, it says write out the new function g of x. So what we want to do is let's go ahead and start by writing our first function f of x equals 4 parentheses x plus 6 squared minus 3. Pardon me, y'all. Now, what we have to do here is we actually have to take this in two parts. And the reason we have to take this in two parts is because we have an a value. So in our rule, we have this 3, which I'm going to write in red. And then we have kind of the rest of this, which I'm going to write in a different color altogether. Let's go ahead and go with this kind of purple here. 3 f of x minus 2. So the reason I'm going to write these in two parts is because you actually have to do this in two separate parts itself. Okay, so let's take a look at our new function g of x. And for g of x equals this red right here, this 3, we actually have to first just multiply f of x as it is on its own. So I write 4 parentheses x plus 6 squared minus 3. And just like we did in our previous problem, I know that when I distribute this 3, it goes towards the coefficient a. 3 times 4 is 12. And what I have on the inside does not change at all. So I have x plus 6. However, since this x minus 2 is inside the function, inside this function, I'm going to leave a bit of space, squared. And 3 times our constant at the end, 3 times negative 3 is negative 9. Okay, now switching back to this purple, the reason this is so tricky is because now we have to take this x minus 2 on the inside of the function, and we're going to have to add that minus 2 on the inside of this function. Oh, I'm so sorry. To make these colors a little bit more coherent, let me switch this and put this in green, the minus 9. Okay? Alright, and now at this point, you can actually finish out the function. So we say, okay, we have our g of x function is equal to, our coefficient is 12, parentheses, on the inside, positive 6 minus 2 gives us x plus 4 squared, and on the outside, from this distribution, we have negative 9. Alright? So this gets one layer trickier because after you go ahead and distribute your a value, you then have to do any addition or subtraction to the the c or d value on the inside. Okay, let's go ahead and look at a second example that's going to be a little bit different. Okay, for example 2, we have the function f of x equals 2 parentheses x plus 4 cubed minus 2 is changed to h of x equals negative 5 f of x plus 8. Describe the transformation. Okay, we know that the negative symbol right there tells us that we have a reflection, comma. We know that the 5, separate from the negative, is still greater than 1, so what we have is a vertical stretch. And since this plus 8 is on the outside of the function, we know that the graph will shift up 8. Okay, so describing the transformation is pretty easy. Now let's look at part B where this gets a little bit trickier. So we write our original function f of x is equal to 2 parentheses x plus 4 cubed minus 2. And the same way that I did in the previous one, I'm going to write my rule in two colors. We have firstly the a value, -5, and then we have our f of x plus 8. Okay, so what's this going to look like? Well, my new function g of x, the very first thing I do is I take the a value and I multiply it by everything that is inside, everything that is simply f of x. So I see that my f of x is 2 parentheses x plus 4 cubed minus 2. Okay, so this implies that I'll do g of x is equal to -5 times 2, which is -10. And I know that the inside of my function is unaffected by the a value, so I write parentheses x plus 4 cubed. Now notice I didn't leave any space here because this plus 8 is on the outside of the function, not the inside of the function. And -5 times -2 is positive 10. Now from here, switching to this purple, because we have this plus 8 on the outside of the function, I now add plus 8 on the outside of the function. And this allows me to write our final form of g of x. It is -10 parentheses x plus 4 cubed plus 18. Alright, I hope this helps. Now, we're going to do one final example where I combine basically example 1 and example 2, so I'd really highly encourage you to stick around for this final example. Okay, for example 3, I'm going to move very quickly through the transformation. I see that we have a negative symbol in front, so I know that this has been reflected, comma. I see that devoid of the negative, we have 1/2, which is a vertical compression, because 1/2 is less than 1. I see over here we have that x minus 5. If I were to set it equal to 0 and add 5 to both sides, you would see that it shifts to the right 5, comma, and it's going to go up 3. Okay, so the transformation is easy. However, the tricky part is going to be writing out our new function, k of x. Okay, so I have f of x is equal to 4 square roots of x minus 5 plus 6. And my new function, k of x, is going to equal, the rule is -1/2. And remember, I'm going to use different colors here. -1/2 f of x minus 5 inside the function plus 3 on the outside of the function. Okay, so for my new function, k of x, I know that the first thing I always start out with is the multiplication of the a value, -1/2, big parentheses, times our original f of x, 4 square roots of x minus 5 plus 6. Now from here, -1/2 times 4, I can just do the math off to the side. I can write it as 4/1. And -1 times 4 is -4 over 2 times 1 is 2 is equal to -2. I know that the inside of my function does not change, and so I have the square root of x minus 5. But notice, because I have that minus 5 on the inside of the function, I leave a space underneath the square root. Next, my -1/2 times 6 becomes 6/1. And -1 times 6 is -6 over 2 times 1 is 2. And -6 divided by 2 is -3. So out here I can write -3. However, because there's a plus 3 on the outside of the function, I want to leave a little space there as well. So I now look inside the function. I see this x minus 5, so I need to include another minus 5 inside the function. And I see this plus 3 on the outside, which I include right there. And this allows me to write the final form of k of x. -2 square roots of -5 minus 5 is -10. And -3 plus 3, well, that's a 0 pair. That completely cancels out. And so here is my final form of k of x.